Good afternoon. My name is Jeremiah Flores. In this assignment for ITT 210, we'll be going over how to create a simple calculator program that uses assembly language for its core operations, and a C program to interface with it as well. The goal of this project is to show how a high-level language like C can call assembly routines to perform basic arithmetic operations like addition, subtraction, multiplication, and division. The program will ask the user to enter two numbers and an operand, such as a plus sign, subtraction sign, multiplication, or division sign. Based on the operand entered, it calls an assembly function to perform the operation, and then it displays the result. This program is split into two main parts: the C program, which is what we are looking at, and the assembly code, which is this. As we go back to the main program, you can see the code itself. The C program handles user input and output, and the assembly code itself will implement the arithmetic operations. As we're looking at the C code, the main function begins with printing a simple calculator title. It then prompts the user to enter an operand and two numbers. The program itself uses scan_s to safely read the user's input and for the operand and the two numbers. This is a secure alternative to scanf in itself and helps avoid potential buffer overflow issues. Once we get to the operand and numbers, the program checks which operand was entered and calls the corresponding assembly function using extern declarations, as you can see here. It then prints the result of the operation, which is returned from the assembly function. Let's take a look at the assembly code itself. We have four public functions: add_ASM, sub_ASM, multiplication _ASM, and division _ASM. These functions will perform the addition, subtraction, multiplication, and division respectively. As you can see here, you got the addition, subtraction, multiplication, and finally division. And the add_ASM function, as you can see here, the first step is to move the first argument into the EAX register. Then we add the second argument to EAX. Finally, the result is returned to EAX using the RET instruction, as you can see here. This is how the result of the operation is passed back to the C program. Same thing goes with subtraction, multiplication, and division. We'll follow the same process. The arguments are moved into the registers, the operation is performed, and the result is returned to the EAX register. So let's go ahead and get started into seeing how this works. So we'll go ahead and clean the solution. Then we'll debug. So first, we'll enter a addition operand. As you can see here, 2. We'll enter our first number, which will be 15. Enter the second number, 15. Now let's try it with subtraction. Let's see here. Build. Start debugging. Let's do multiplication to begin with. 1, 9. As you can see, the result is 0. It's staying for some reason, so I'll have to go back and check on that. It's supposed to say 9, but once the correct output is showcased, you'll know how that's when the program is working, of course. I believe I'll have to go back and change number 2 in this place right here. But like I said, once the correct output is shown, this will basically demonstrate how to integrate assembly language routines into high-level C programs to perform basic arithmetic operations. Like I said, it will showcase how assembly can work with C to optimize performance while maintaining a user-friendly interface. One of the challenges, of course, when creating this code is, of course, what we just seen right here, but then as well as correcting any type of properly linked conventions with the code, such as warning signs that may have populated. It was important to make sure that the function names matched in both the C and assembly files as well. But I'd like to thank you for watching. I hope you have a better understanding of C and how the assembly language can work together in a simple calculator program. Have a good night.